So this is going to be a quick summary video on excess questions for higher chemistry. So what we need to know initially is just what is a limiting reagent or reactant, and what is an excess reactant. Well, the term excess in chemistry means having more of a chemical than is needed for the reaction. The other reactant will then be described as being the limiting reactant. And it is the limiting reactant or the limiting chemical which determines how much product can form. So if you're doing a mole equation, you use the limiting chemical to predict how much product forms. Now you might ask, why would we ever bother using an excess chemical? Well, if we have an expensive or a dangerous chemical, we would want to make sure that it is all used up, either to protect ourselves or to help us make sure we haven't wasted any money. So we would use an excess of the other chemical in that reaction so that all of it is used up. Now, how we do excess questions is going to be a four-step process. You're always going to be given enough information to work out the moles of both reactants. That's how you can identify it's an excess question, and that is your first step, work out moles. Second step is you're going to use the mole ratio to compare the number of moles that you have of each chemical to what you would need. And from that, you'll be able to identify the limiting reactant and the excess reactant. The limiting reactant is the most important one because for step 3, you're going to use the mole ratio of the limiting reactant to your product to determine the number of moles of product. And the final step will be to answer the question, which will be to work out some bit of information about the product. For these types of questions, you are going to need to remember the 3 triangles or the 3 types of equations you can use, and make sure that you identify if a chemical is a solid, a solution would be AQ, or a gas, and pick the appropriate set of equations to use, and always remember to use that molar ratio. So we're going to go through a worked example now. So for our worked example here, what we're going to do is we are going to look at calcium carbonate reacting with nitric acid to produce calcium nitrate, carbon dioxide, and water. In the equation, we've been told that we've got 2 grams of calcium carbonate and we've got 100 grams per mole. So when we're calculating our moles of both reactant for our calcium carbonate, CaCO3, we know we've got a mass of 2 and a GFM of 100. Now N equals M divided by GFM, which is 2 divided by 100, which is 0.02. Sorry, make sure that decimal point is in there. 0.02 moles. Now we're going to look at our nitric acid. So we've got nitric acid here. We've been told 200 centimeters cubed and 0.1. So for HNO3, what we've got is a concentration equals 0.1 mole per litre, and we've got a volume of 200. Now that's centimeters cubed. We do not like centimeters cubed. We're going to divide by 1,000, and that's going to give us 0.0. No, it's not. It's going to give us 0.2 litres. Now N is equal to CV. That's going to be 0.1 multiplied by 0.2, which also equals 0.02. So we've worked out our moles of both reactants. We've got 0.02 and 0.02. Second step is to make sure we use the molar ratio. So for calcium carbonate, we've got a 1 to 2 ratio. And we've got, what we have is 0.02 and 0.02. Now if we look at what we need, if we've got 0.02 here, we're going to need 0.04. So that's what we would need. So if we compare here, we have less than we need. And that means that is limiting. So the HCl is limiting. That also means that our CaCO3 is excess. Now, some questions actually, all they ask you to do is identify which one is limiting, which one is excess. It doesn't matter which one of these you start with to work out how much you would need of the other. You could have done it the other way around. You still would have found out that the nitric acid is limiting and the calcium carbonate is in excess. Now remember, we are going to use our limiting reagent to predict our product. Now step 3 is looking at our ratio to determine moles of product. So we have 2 to 1. Remember, we calculated 0.02 moles here. So that means we're going to have 0.01 moles of carbon dioxide. Okay, remember, it is what we have, not what we said we would need. So 0.02 to 0.01. And finally, we'll be able to answer the question. And to answer the question, it is what volume of carbon dioxide, what volume, and you've been given the volume of 1 mole is that. So this is going to be molar volume. So for CO2, we know that we've got N equals 0.01, and we've got a mole volume of 24. Now volume is equal to N times mole volume. So that's going to be 0.01 multiplied by 24, which is 0.24 litres, or that is also equal to 240 centimetres cubed. So that has been a quick go over the terms limiting and excess and a worked example of how to approach an excess question. Hopefully that helps.